Okay, I'm about to show you how to balance a chemical equation that ends up having an odd number of oxygens. And when that happens, people get really stressed out because they don't know what they're supposed to do. So really quick review of balancing equations. The only thing that we're allowed to do is multiply by a coefficient. We cannot change subscripts, and we're not allowed to multiply by like half a molecule or a quarter of a molecule. We have to use whole numbers. And so let's just really quickly go through balancing this, and I'll show you where the trip up happens, okay? Sorry, my dog is sitting next to me and he's itching himself. So right here we have 2 carbons, 6 hydrogens. We have 2 oxygens right there. We have 1 carbon, 2 oxygens in that compound, and then we have 2 hydrogens, 1 oxygen. So we always follow this list right here. We do metals, non-metals, not hydrogen and oxygen, then hydrogen, then oxygen. So we don't have any metals here. We can move on to non-metals that aren't hydrogen and oxygen. That means we're going to start with carbon. So right here we have 2 carbons, right here we have 1 carbon. What we're going to need to do is multiply this CO2 by 2. The reason why we want to do that is because we want to have our carbons be even on both sides, and you want to multiply your smaller number by a number that will get you to the side that has the bigger number of the atom. So this ends up distributing, and it becomes 2 carbons, 4 oxygens, because 2 times 2 is 4, 1 times 2 is 2. So now look, our carbons are happy. We have 2 on the left, 2 on the right. We can move on to hydrogen now. There are 6 hydrogens on the left side. There are 2 hydrogens on the right side. That's not even, right? 6 is way bigger than 2. So what we want to do is we want to multiply our smaller number, which is 2, by a number that will get it to 6. And that number ends up being 3. 3 times 2 is 6. So we put a big 3 in that coefficient spot first, and then we distribute down here as we're taking inventory. So 3 times 2 hydrogens is really just 6 hydrogens. And 3 times 1 oxygen is really 3 oxygens. We always go back and check everybody who we've already taken care of. If you don't do that, you will mess it up, I promise you. So, look at carbons. Carbons are still chilling, right? There's 2 and 2. Look at hydrogens. There's 6 and 6. They're also chilling. So now we can go on to oxygens. We have 2 over here, and in total we have 4 plus 3 oxygens, which is really 7 oxygens. Right here should be where you're freaking out a little bit, right? Because we know that there is no whole number that we can multiply by 2 to make 7. Because technically 3.5 times 7 or times 2 makes 7. But we're not allowed to put 3.5 because you can't use half a molecule inside of a chemical reaction. That's that would be like changing a recipe when you're making cookies, and that's not going to give you the same cookies. So there's something called the half molecule method. I made a video on that one. I'm not a crazy huge fan of that method, but a lot of people it works for them, and that's cool. I want to show you what I do in my brain. Okay, I call this the least common multiple method. I'm sure that I didn't make this up. This is just what my brain uses, so I'm not taking credit. So when I have an odd number of oxygens on one side and then an O2, so there's only 2 oxygens on the other side, I have to be able to figure out what number they're going to have in common, the lowest number that I can think of, and that's called the least common multiple. You guys learned this in math a long time ago. So what I like to do in my brain, but you can write it out for yourself, I like to say, okay, if I count by 2s, I have 2, 4, 6, 8, 10, 12, 14, 16, blah, blah, blah. And on this side, if I count by 7s, I'm going to have 7, 14, 21, 28, 35. What I want to do is go down both of these lists and see the first number that they have in common. So obviously they aren't going to have 7 in common because 7 isn't even, and it's the whole thing with the 2s. So I can move on to 14. Look, 14 is the first number that they have in common. So I'm going to want to do whatever it takes to make sure that there's 14 on the left side and 14 on the right side of oxygens. Again, you can only really, most of the time you're going to have this issue when you have oxygens, okay? The half molecule method you can really only use for the oxygens. Anyways, sorry, I digress. So you're going to end up wanting to have 14 oxygens over here. So you're going to just want to multiply this guy by 7 to make it 14, right? Because 7 times 2 is 14. And then on the side that had 2, sorry, I was on the wrong side. Okay, the side that had 7 oxygens, I'm going to want to multiply all of those coefficients by 2 to make it be 14 total. So what I'm going to do, I'm erasing right now, and I'm really just saying 4, because 2 times 2 is 4. And then I have 3 right here. I'm going to be multiplying that by 2, so that becomes 6. And I'm going to redistribute. So 4 times that original 1 is 4. 4 times that original 2 is 8. 6 times that original 2 is 12. And 6 times that original 1 is 6. And then we know that 8 plus 6 is really 14 oxygens, which is exactly what we wanted. So our oxygens are happy now. But we got to go back and check, because I think we just messed a few people up. So I'm going to go back to carbon. I have 2 carbons on the left. I have 4 carbons on the right. What do I need to do? I need to multiply that smaller number of carbons by a number that will get me to the bigger number, which means I have to multiply that carbon by 2. This becomes 4 carbons. This becomes 12 hydrogens, because remember, this distributes. So now, I just need to go back and double check. I have 4 carbons, 4 carbons. I have 12 hydrogens, 12 hydrogens. I have 14 oxygens and 14 total oxygens. So your coefficients here will be 2, 7, 4, and 6. I will tell you right now, one of the biggest mistakes people will make, they'll do a beautiful job, a perfect job at making sure that they get their least common multiple. They get that 7 in there on the left side. They multiply the other side by 2, but they forget to go back and double check everybody. And that's not a balanced equation. See how our carbons weren't originally happy with each other? We had to go back and fix it. So that's one way I like to solve that type of problem.